Imagine looking up at the night sky. You see stars, planets, and distant galaxies. It feels vast, but everything you see, everything we've ever observed, makes up only 5% of the universe. The rest, it's hidden. Scientists call it dark matter. It doesn't emit light, it doesn't reflect it, and it doesn't block it. It's a ghost in the cosmic machine, an invisible weight that holds the universe together. But how do we know it's there? In the 1930s, astronomers noticed something strange. Galaxies were spinning much faster than they should be. Based on the amount of visible matter stored in gas, they should have flown apart, scattering into the void like spinning tops. But they didn't. There was an invisible force, a cosmic glue, providing the extra gravity needed to hold them together. This was our first hint that the universe is far heavier than it looked. For centuries, we thought we understood gravity. Isaac Newton showed us that planets move in a predictable dance, governed by the mass we can see. Later, Albert Einstein took it further, explaining that gravity is the warping of space-time itself. Their equations are the bedrock of physics. They've guided us to the moon and beyond. But when we look at the scale of entire galaxies, these legendary laws start to crack. According to Newton and Einstein, the outer stars of a galaxy should be lagging behind, struggling to stay attached. Instead, they race ahead as if gripped by a phantom hand. This isn't just a minor error. It's a sign that we are missing a massive piece of the cosmic puzzle. Decades later, Vera Rubin provided the smoking gun. She observed the Andromeda Galaxy and found that stars at its edges were moving just as fast as stars near the center. This defied the laws of physics as we knew them, unless there was a massive halo of invisible matter surrounding the galaxy. Rubin faced a wall of skepticism. In a field dominated by men, she was telling the world that the universe they saw was an illusion. But she was persistent. She showed that this wasn't an isolated incident, it was happening everywhere. From small spirals to giant clusters, the missing mass was the rule, not the exception. Rubin's work transformed dark matter from a fringe theory into a central mystery of modern science. We can't see dark matter, but we can see its shadow. Gravity bends light. When light from a distant galaxy passes through a cluster of dark matter, it curves, creating a distorted image, a cosmic magnifying glass. This effect, called gravitational lensing, allows us to map the invisible. It is a reminder of what Feynman often emphasized, that nature's imagination is far greater than our own. We aren't just looking at light, we are looking at the fingerprints of a phantom. Every warped arc of light is a piece of evidence, telling us that even if we can't touch it, the universe is built on a foundation we are only just beginning to name. We can see where dark matter is concentrated, even if we can't see the matter itself. It's like seeing the wind by watching the trees bend. But take a moment to realize the strangeness of what we are saying. If dark matter is everywhere, it's not just out there in distant galaxies. It is here, right now. As you watch this, billions of dark matter particles are streaming through your body, through your house, and through the very earth beneath your feet. They are like cosmic ghosts, unaware of our existence, just as we are mostly unaware of theirs. We are living in a crowded universe, sharing the same space with a massive, invisible reality that we cannot touch, smell, or feel. It is a haunting thought that the most important stuff in the cosmos considers us, and everything we know to be practically transparent. If dark matter is invisible, how can we be so sure it's a thing and not just our math being wrong? The answer came from a cosmic car crash known as the bullet cluster. When two massive clusters of galaxies collided, the visible gas slammed together and slowed down like a pileup on a highway. But something else, the dark matter, sailed right through the wreckage without stopping. It didn't collide. It didn't heat up. It just kept going, proving that dark matter is a physical substance, independent of the atoms we are made of. It was the moment the ghost became a reality. The search for dark matter is one of the greatest detective stories in history. Deep underground, in abandoned mines, scientists have built ultra-sensitive detectors shielded from cosmic rays, waiting for a single dark matter particle to bump into an atom. We are looking for particles with names like WIMPs, weakly interacting massive particles or actions, tiny ghosts passing through your body by the billions every second. In space, telescopes like Euclid and James Webb are mapping the large-scale structure of the universe, looking for the telltale signs of its influence. So far, the particles themselves remain elusive. This isn't just about invisible galaxies or mysterious matter. It's about everything we see and everything we can't. The very fabric of reality may not be made of matter alone. It could be a complex web of invisible forces we're only beginning to understand. Look at the large-scale structure of the universe. It's not a random scatter of stars. It's a cosmic web. Dark matter forms the scaffolding, the invisible bones upon which the meat of the visible universe is hung. Without it, galaxies would never have formed, stars would never have ignited, and you and I would not be here to ask these questions. To understand dark matter, we must also recognize its mysterious partner, dark energy. While dark matter acts as the cosmic glue pulling things together, dark energy is the opposite. It is a mysterious force pushing the universe apart at an accelerating rate. Together, they dominate the cosmos, leaving our normal world of atoms in the tiny minority. Think about it. If dark matter makes up 85% of the total mass and dark energy makes up 70% of the total energy density, then how much of reality is hidden from us? And here we stand at the edge of knowledge. We can calculate dark matter's existence perfectly, but we cannot explain why it behaves as it does. The deepest understanding begins with honesty about what we don't know. What Feynman understood so well is that the more we discover, the more we realize that reality is a series of beautiful questions, unanswered mysteries that are woven into the fabric of the universe. We've only just begun to scratch the surface of the cosmic unknown. So, what is dark matter? It's a ghost that haunts the edges of the universe, shaping galaxies, bending light, and challenging us to look beyond the visible. It is not a failure of science, but a triumph of its curiosity. Nature simply is this way, and in its vast, silent complexity, we are merely seekers on a journey to understand.